Okay, so I'm going to do an instance of limiting reactants. As you know, these problems approach the question from a couple different angles. So this won't be an example for everything, but it'll be a good example of how we do limiting reactants. All right, so let's look at it together. Aqueous hydrobromic acid reacts with sodium hydroxide to produce aqueous sodium bromide and liquid water. All right, so we're given some masses here, and we're asked to calculate the minimum mass of HBr that's left over at the end of the reaction. And immediately my stress level goes up, right? There's a lot here. So I'm going to go over to my whiteboard, and I'm going to snapshot the question over here, right? Aqueous hydrobromic acid will react with sodium hydroxide. So I'm going to make those notes first, okay? Hydrobromic acid and sodium hydroxide produce aqueous sodium bromide and liquid water. Now, I don't think the states have anything to do with it, but just in case, I'll put those here. See what I'm talking about with the states? I don't think it means anything, but aqueous hydrobromic acid reacts with solid sodium hydroxide to produce aqueous sodium bromide. Okay, I got that. Now I'm going to set this up. You've seen me do this before many times. I'm going to set up a table here, and I'm going to let this be one column, and here's another column in my table, and here's another column, and here's my fourth column, right? So we'll set the table up, and we've now set this up. Now, the masses is what we're given. Suppose 53.4 grams of hydrobromic acid is mixed with 15 grams of sodium hydroxide. And before I really even understand what the rest of the question is asking, I'm going to say, you know what? I know I'm always, if I'm given the mass, I'm given also my mole ratios, I'm always going with moles. So let's go ahead and calculate the moles, right? And we know how to do that is we're going to put the molecular weights here, right? And I'll show you, let's calculate the molecular weights with our Alex calculator. Calculate here. Looks like I already started it. Atoms, HBr is going to be H plus bromine equals 80.9. And you see we put that there. I put the dot, dot, dot to remind myself it's in my calculator. All right, let's come back over here. Store. Is it there? Yep. Okay, let's clear that out. And the other one is sodium hydroxide, which is sodium plus oxygen plus hydrogen equals store. Okay, so those are both in my calculator now. It's right there. All right, clear those out. Now we know that in order to get the moles, I'm going to take 53.4 and divide it by 80.9. 53.4 divided by, and I'm going to use the exact number here, 80.911, whatever, okay, equals store. So that's my amount, the amount of moles of my HBr. Did I store it there? I did. Let's clear that out. Let's do the other one now. 15, right, divided by sodium hydroxide, which was 40, I think. Yep, 40 equals 0.375. So store those in my calculator. They're all there. Okay, clear it. And let's put that now in my table, right? So let's show out. Let's put that. All right. So 0.66, 0.375, dot, dot, dot means it's all in. Now I need to say to myself, which is the limiting reactant? These look like they go 1 to 1, but these are not 1 to 1 moles. So let's calculate the limiting reactant. You've seen this before. I'm going to say, if I use all of my sodium hydroxide, how many moles of sodium bromide will I get? And alternatively, if I use all of my HBr, how much will I get? So we set those mole ratios up. I'm using about 0.375 moles. It's a 1 to 1 ratio. That's going to give me how many moles of sodium bromide? And the answer, I think, is obvious. It's going to, but it looks like I didn't write it here. It's going to be, since this is going to be 0.375, right? Because it's 1 to 1. And these cross off, right? So if I have 0.66, these are also 1 to 1. This is going to give me 0.66 dot, dot, dot. And I can see that this is my limiting reactant, right? So I am going to have some HBr left over. If I use 0.66 HBr, I'm going to get that much, but I don't have enough sodium hydroxide for it. So I'm going to say to myself, well, let's see. The HBr that's used plus the HBr that's left over is going to be my HBr total. This is my total right here, 0.66. Do I have that written down? Yep. All right, so let's calculate this. Let's calculate how much is used. How much is used? If I if I use 0.375, let's see, it's going to be, I don't have to calculate that. Do I have it written down? Yeah, I do have that written down. Okay. Do I have this written down? Yeah. I'm going to use 0.375, right? Because that's how much was used. I made 0.375 sodium bromide, and we convert that back to HBr. So it must be 0.375 that's used. That's a subtraction problem, right? 0.66 is how much I had available. This is how much I used. This is how much is left over, is 0.285. Let's go back over our calculator then and say it was 0.66 minus, and what was the other amount? 0.375 minus 0.375 is going to be about 0.285. That's how much I have left over. That's 0.285 moles of HBr. Let's go back and look at that. That's 0.285. I don't really have room over there. Let's come over here. 0.285 moles of HBr. And now I calculate that to grams of HBr, and I'm done. That'll be my math, and I just do that by multiplying by the molecular weight. If you've gotten this far in the course, you know how to do that. 0.285 moles is how many grams. Let's store that in there, and it's going to be times the molecular weight of HBr, which is 80.9, equals 23.055. Store that, and that's how much I have left over, right? That's the minimum mass that can be left over. That's the minimum mass that can be left over. Round your answer to 2 sig figs. So it looks like it's going to be 23 point even, because it's 2 sig figs there. We'll check it. Hopefully we'll get some green here, and bam. All right, so hopefully that's helpful. The critical point here, I think, is for the limiting reactants is calculating how much I can make if I have sodium, if I use all my sodium hydroxide, and I do that with an arrow like this, or how much I can make if I use HBr and I circle the smaller amount. All right, hope that's helpful.